Yesterday, we looked at y equals mx plus b, slope-intercept form. Today, we're looking at the other part of the lesson. And so the topic today is the same topic as yesterday. It's slope-intercept / standard form. We're looking at day 2. Yesterday was slope-intercept form. Today is standard form. We've got our date, January 14th. It is Friday. We do not have school on Monday. We got a four-day week coming up next week, so that's going to be nice. I'm not really going to be able to do a lot of color coding like I did yesterday because standard form doesn't really have nice numbers that you can point to and say, that is the slope, that is the y-intercept. One of the main reasons why we use slope-intercept form so much more than we use other forms like standard form is because in terms of convenience, slope-intercept is probably the most convenient form to use because it has two exact numbers that we can use with the graph itself. Standard form, not so much. We will eventually be graphing from standard form. However, today, we are going to learn right here, we're going to learn how to convert from standard form into slope-intercept form because slope-intercept form is so much more common than standard form, and I think it's a lot more convenient to use as well. So let's get started here. So it says linear equations are also frequently written in standard form. Now, I would say frequently is a good word for that. However, most of the time, standard form isn't used to graph things as often as slope-intercept form is used to graph things. Standard form oftentimes is used to solve word problems. We will not be seeing word problems today. We will see word problems later on in this unit, and a lot of the word problems that we read will turn into standard form when we write the equation. But in terms of graphing, we usually graph from slope-intercept. You can graph from standard form. That will also be a lesson later in this unit, but most of the time we graph from slope-intercept. But that's all beside the point. At this point, let's get this written down. Standard form looks like this. It's a capital A, make sure the A is capitalized, and then lowercase x, so AX, plus capital B with a lowercase y equals a capital C. So we got AX plus BY equals C. A, B, and C are capital letters. And it's important that you capitalize those letters because that does matter. There is a difference between uppercase and lowercase when we're dealing with math concepts and formulas. And really the only similarity that we're looking at between yesterday's notes and today's notes is the fact that we have X and Y in the formula. So yesterday, Y equals MX plus B, we had X and Y in the formula. Today, AX plus BY equals C. We have X and Y in the formula. That's really the only similarities that we're going to see between those two. Let's do a side-by-side comparison here real quick. So the similarities are the fact that X and Y are there. What are some differences that you notice? There's some big differences here. What do you notice that's different between those two? Ash? They are arranged very differently. Can you be more specific? Okay. Can anybody think of I would say 100% they are arranged very differently. Can anybody describe more specifically what is one of the major differences of this arrangement? Even though they have X and Y, what are some other differences you notice? So you notice a difference of arrangement. Ash, what else do you have? Yeah, the A and B, first of all, well, the B here is a capital B. And this is a good thing for me to point out here. This capital B and that lowercase b, not the same thing, not even close. Which again, it's important to have the capital letter for B over here because the lowercase letter for B over here means the y-intercept. That's not the y-intercept. In fact, I need to be really, really clear about this. Standard form does not give you the slope or the y-intercept. If we look at just real quick some examples down here, 4x plus 5y equals negative 30, none of those numbers are the slope or the y-intercept. Which is why I was mentioning just a minute ago, slope-intercept form is a lot more convenient because it gives you two specific numbers that can be used on the graph. None of these numbers relate directly, at least at first, relate directly to what's going on the graph. So it's a little bit more challenging to graph using standard form. So the b here is not the same as the b over here. That's a very important thing to mention. Outside of that, we've got a capital A. There's no A on this one. We've got a capital C. There's no C over here either. And you might notice that X and Y are on the same side with standard form. X and Y are on different sides of the equation over here. In slope-intercept form, Y is all by itself on this side of the equation. Y is being multiplied by B on standard form on this side of the equation over here. So there are quite a few differences. The only real similarities are the fact that we have X and Y. And X and Y just mean it could be any XY coordinate on the graph. What we are planning on doing today, though, is transferring or converting this form of an equation to make it look like slope-intercept form. That is going to take us 2 steps of algebra to do. So we are going to be using some algebra today, just to give you a heads up on that. One last thing I want to mention, if you look through these different equations here, 1 through 8, do you notice anything about the numbers that are with X and Y? And how they're a little bit different than the numbers that we saw with M and B recently? Like the types of numbers, 4, 5, negative 30, 2. This would be a 1 if there was a number next to the Y, 3, 1, negative 3, 12, 1, negative 1, negative 8. Whereas with slope-intercept form, we had like negative 3/5, or we had 1/4, or negative 5/2. So do you notice anything about the types of numbers we have on this page here versus yesterday's, Ash? Like for the B values? Okay. Do you notice that there are no fractions? Yeah. So none of these equations, and even on the next page, none of these equations have fractions. So when I was telling you when we were writing down this formula, use the capital letters for A, B, and C. What do you think those capital letters might mean? And the fact that there are no fractions in those equations down below. Any ideas on what those capital letters might indicate? All right, here we go. Capital letters. Mean integers. So these capital letters over here, A, B, and C, that means that those values have to be integers. That means they have to be positive or negative whole numbers. Every single time you see something written in standard form, it will have a whole number, positive or negative, for the value of A, whole number, positive or negative, for the value of B, a positive or negative whole number for the value of C. So the capital letters over here mean that that's a positive or negative whole number, positive or negative whole number, positive or negative whole number. In that formula, those capital letters mean that. So you will always see that with standard form. You'll always start with positive or negative whole numbers in the equation. X and Y will always remain X and Y, just like you saw in slope-intercept form yesterday. And then, Miss Eddie, will you check my, is that the correct capital? I think it is. It's AL, right? Yeah, okay. That's what I thought. All right. So we got the AL and we got the OL, and OL is like, yeah, or a city, or okay. Got it. That's what I was thinking. All right. I get sure I got that right. I'm not a language arts or social studies teacher, so sometimes I'll ask those questions. Okay. So that's kind of our setup for today. We are going to be doing a lot of practice with this. Hopefully we'll have plenty of time to continue working on the assignment that we got yesterday. So it says, equations written in standard form can be converted into slope-intercept form by solving for y. What that means is we need to get this lowercase y all by itself, and we're going to keep it on the left side of the equation because we want to get it from here in standard form to here in slope-intercept form, where y is all by itself on the left side of the equation. So there's going to be 2 steps of algebra that we have to do, and I'm going to write down those 2 steps for you off to the side. So the directions tell you to write each equation in slope-intercept form and identify the slope and the y-intercept. We did that yesterday. We'll be able to do that today too. But converting from slope-intercept to standard form, there's going to be 2 steps. So follow these steps. And good thing, there's only 2 steps, so there's not a whole lot of work to do to make this work. So step 1, add or subtract the term with x. Add or subtract the term with x. And actually, you know what? I'm going to make that a little bit longer. From both sides of the equation. Because whenever you do something using algebra, you have to do the same thing to both sides of the equation. So let's just start with problem number 1, and we're just going to do step 1 to begin with. We'll just start with step 1. We'll do step 1 so you can see what that's going to look like. So basically what we're looking at here is every single time we want to get a variable by itself using algebra, just as a reminder, we have to move everything away from it that's on that side of the equation. And so when I solve an equation, I usually draw a vertical line right down through my equal sign, just to make sure I know where to keep my equal sign as I'm solving. So the equal sign should always remain in the same spot vertically as you work your way down. And if I want to get y by itself, that means everything else over here has to go away. And so step 1 says to add or subtract the term with x from both sides of the equation. Now this is a positive 2x right here. So if I want to get rid of 2x, do I have to add 2x or do I have to subtract 2x? If I want to get rid of 2x, do I have to add it or subtract it? Subtract it, yeah. I want to get rid of it, so I have to take it away, so I have to subtract it. So I'm going to subtract 2x here, and it says do this to both sides of the equation. So I'm going to minus 2x over here as well. So I'm taking away 2x from the left, and if I have 2x's on the left and I take both of them away, that means they're no longer there. They cancel out. It's like 4 minus 4. It goes away. It's 0. 2x minus 2x. It goes away. It's 0. And on the right-hand side of the equation, I've got 3 minus 2x. So going back, doing a little bit of review here, am I allowed to put those 2 things together? Can I put 3 and a negative 2x together into the same term? Elle, I'm seeing you shaking your head no. Why not? Yeah, if there's a number by itself, and then there's a term with a variable, negative 2x, a term by itself, a number by itself cannot be combined with a term that has a variable. So 3 minus a 2x cannot be put together to equal 1x. That is not how that works. They have to stay separate from each other. Those would not be like terms. So on the next line, we're going to rewrite this. We're going to say everything over here is gone except for the y. So we've got y equals. And then with slope-intercept form, just real quick, do we write the term with x first or do we write the regular number first? Based on what we did yesterday. So slope-intercept form. Should we fit this on the, okay. So slope-intercept form, do we write the term with x first or do we write the regular number first? We look down here. Term with x first or regular number first? Term with x first, okay. So instead of writing 3 minus 2x on the next line, I'm going to write negative 2x, and that's a positive 3, so plus 3. We're arranging it. Yeah, we're arranging it to look like slope-intercept form. And because my slope is a whole number here, or an integer, I'm going to go ahead and just change this to a fraction and write 2 over 1x plus 3 like we've been doing. So y equals negative 2 over 1x plus 3. And the reason why I put the 1 underneath here right now after step 1 is because this particular problem only has one step. The goal of this problem, or the goal of all of these problems, is to get y by itself, and we were able to do that just in one step. So we solve for y, it's all by itself. So we didn't even need to figure out what step 2 was in order to solve this first one. So write each equation in slope-intercept form. So we've done that here. This is slope-intercept form here. Now we need to identify the slope and the y-intercept. So I'm going to write m equals, and I'm going to write b equals. And on number 1, what's the slope of that line? This is what we've been working on the last few days. What's the slope of this line here? -2/1, yeah. The number next to x is the slope. The fraction is our slope, -2/1. What's the y-intercept? Three, yeah. The y-intercept is 3 because the value of b, the number after x, is our y-intercept. And so in this particular problem, it's 3. So on that problem there, we only needed to do one step to get y by itself. But on the next one, number 2, we're going to have to add that second step to our instructions over on the left. But let's start with the first step here. So number 2, here we go. Start by drawing your line down. And we are going to, step 1, add or subtract the term with x from both sides of the equation. So here's our term with x, it's 4x. So if I want to get rid of 4x, do I have to add that or subtract it? I want to get rid of a 4x. Am I adding it or subtracting it to get rid of it? Yeah, subtract it. So take away 4x, so minus 4x, minus 4x. 4x take away 4x, that's 0, so it goes away, it cancels out. And on the left-hand side, I've got 5y equals, and we always write our term with x first when we're converting to slope-intercept form. So I'm going to write -4x, and that's a -30, so I'm just going to write -30. -4x minus 30. My next question for you is y all by itself? No. What's happening to it right now? It's got a 5 next to it. All right, so we have to do a second step here. So off to the side, we're going to have step 2. Step 2 is divide everything by the number with y. And in parentheses, I'm going to write if possible. So divide everything by the number with y, if possible. And I'm saying if possible because on the first problem, there wasn't a number with y, so we didn't need to do it. You won't always have to perform step 2. You always have to do step 1, but you don't always have to do step 2. So we're going to divide everything by the number with y. So what number is with y? If we look up here at number 2, what number is next to y? 5. So we're going to divide everything by 5, which means I'm going to divide the 5 over on the left-hand side. I'm going to divide that by 5. I'm going to divide the -4x by 5, and I'm going to divide the -30 by 5. Divide everything by the number with y. Now, on the left-hand side, if I get 5 divided by 5, well, 5 divided by 5 is just 1, and 1 times y is just y, which means that the 5's cancel out. This is stuff that we've been doing a lot this year, solving equations. So the 5's cancel out there when we divide them. And take a look at what we've got here when we divide -4 by 5. Does that divide evenly, first of all? No. So how should we write this? If we're thinking about slope, how should we write this on the bottom line here? As a fraction, yeah. So -4 divided by 5, if it doesn't divide evenly, just write that fraction, -4 over 5x. Because -4 over 5, that's going to be our slope. Does -30 divide by 5 evenly? Yeah, what does it equal? -6, yeah, so -6. So our slope-intercept equation is going to be y equals -4/5x minus 6. The heater out there is having a moment. All right, so what is our slope for this line here? What is m? That'll be our value of b. That'll be our y-intercept. Yeah, -4/5. So the slope is -4/5, and the y-intercept is -6. All right. What's that? Lowercase b. So lowercase b is not the same as uppercase b up here. Lowercase b has to do with yesterday's y equals mx plus b, where lowercase b was the y-intercept. So there's a big difference between uppercase and lowercase letters between these two formulas. It's a little bit annoying that the same letter is being used and one of them is capitalized and one of them isn't. Yeah, got it. All right, let's move on here. Let's try number 3. So problem number 3, step number 1, add or subtract the term with x from both sides of the equation. The first thing I'm going to do here is, because x is by itself, I'm going to put a number next to it. What number can I put next to a variable that's all by itself? 1. Good. So I'm going to put a 1 next to that x. This will make things a little bit easier as we move through it. By the way, anytime you're working on a problem like this, it will probably make things a little bit easier if you put a 1 next to a variable that's by itself. We didn't do that with the first one here because we want to get y all by itself. So if it's just a plus y, you don't need to worry about it. But if it's anything else, put a 1 next to it if the variable is doesn't have a number next to it already. So step number 1, add or subtract the term with x from both sides of the equation. So this is still a positive 1x here. So I'm going to subtract. I'm going to do -1x from both sides. I'm going to speed things up just a little bit. So I'm going to cancel out the 1x's on the left. And on the left, I'm going to have this -3y remains. And instead of -3y, because it's by itself now, it's a -3y. So we got a -3y on the left, and on the right-hand side, we're going to have a -1x, and that 12 is positive, so plus 12. We got -3y equals -1x plus 12. That's step number 1. Step number 2, divide everything by the number with y, if possible. There is a number with y here, it's -3. So we're going to divide everything by -3. So divide by -3 all the way across. And a -3 over a -3, those cancel out because that just equals 1. So down below here, we're going to have y all by itself, which is exactly what we're trying to get. And a -1 divided by a -3, it doesn't simplify in terms of the numbers, but a negative divided by a negative is always a positive. So instead of -1 over -3, I'm just going to have 1 over 3x. And then I know that 12 divided by -3 is -4. And that's a whole number. So my slope-intercept equation is y equals 1 over 3x minus 4. The number next to x, 1 over 3, that's my slope. That's my value for m. So m equals 1 over 3, or 1/3. My value of b is the y-intercept, which is the number after x, which is -4. So I've got a slope of 1/3 and a y-intercept of -4. Which one? The 4? Because we took a positive 12 and we divided it by a -3. Yep. All right, let's try number 4. I'm going to put a 1 next to the x. And because this is a minus y, I'm also going to put a 1 next to the y. The only time you're not going to put a 1 next to the y is if it's a plus y, and the y is already all by itself. But if it's a minus y, put a 1 next to that, because there will be step 2. You will have to do step 2 on number 4 as well. All right. So 1x minus 1y equals -8. Step number 1, add or subtract the term with x to both sides of the equation. So we got a 1x here, we got to take away 1x, just like we started with on the last problem. Actually, it's the same exact first step. 1x's cancel out. And over here, we got a -1x. So remaining on the left-hand side, we have this minus 1y, which now is a -1y because the stuff before it went away. So -1y equals -1x, and that's a -8. So we've done step 1. We've subtracted the term with x from both sides of the equation. Step 2 now, divide everything by the number with y. And the number with y is -1. So everything here gets divided by -1. The -1's cancel out on the left, leaving us with just y on the left-hand side. And a -1 over a -1, negative over negative is always a positive, so that's just 1 over 1x. And then a negative divided by a negative over here is a positive. -8 divided by -1 is +8. So our slope-intercept form here is y equals 1 over 1x plus 8. All right, what's our slope? What's the slope of this line? On number 4. 1 over 1. Good. And what's our y-intercept? 8. Excellent. All right. Let's go with, let's say 2 minutes. I'm going to let you work on number 5, just number 5. If you get done with 5, feel free to move on, but I'm going to give you 2 minutes to try out problem number 5, and then we will double check that one in a couple of minutes. So see what you can come up with. If you have questions about this, definitely ask. All right, let's take a look at number 5. Any volunteers to tell me what to do first here? Yeah, take away 4x from both sides. So -4x and -4x. With this minus y, I'm also going to put a 1 right next to the y, just so I know that there's a -1 there, and it's not just y by itself. And then we've got, let's see, these 4x's will cancel out on the left, which will give us a negative 1y equals negative 4x plus 0. Or if you want, you could just have negative 4x, that's fine. What's our second step? What do we have to do next? There are 2 steps on this one, so what do we have to do now? Do what? Divide. What are we dividing by? Negative 1. Good. So divide everything by negative 1. Negative 1's cancel right there. And that'll give us y equals negative 4 divided by negative 1 is just 4 over 1. So positive, because a negative divided by a negative is always a positive. And then 0 divided by anything is still 0, so plus 0. Which means we have a slope m equal to 4 over 1 and a y-intercept b equal to 0. So that is it right there for number 5. All right, let's try number 6. Moving on. All right, I think I'm going to go ahead and start calling on some folks just to make sure we're tracking what's going on here. And if you're unsure about what to do, that's okay. That's what this is all about, is learning how to do this. So I'm just going to be asking people, what do we do first? What did we do next? And so let's see. First person I want to find out from is, let's see, Evelyn. What do you think we should do first on number 6? What's that? So step 1 says to add or subtract the term with x from both sides. So which term has x on it on this one? The 3x. Okay, so what should we do with that then? Should we add it or take it away from both sides? Yeah, so subtract 3x from both sides. Good. So minus 3x, minus 3x. Okay. And so when we do that, that'll get rid of the 3x's on the left, which is what we wanted. And then we're going to have a negative 2y equals negative 3x, write the term with x first, minus 14. We still have a number next to the value of y, which means we got to do something else. And let's see, Gwen, what do we have to do next? We've done step 1. Step 2 says to divide everything by the number with y. So what should we do here? So step 2 says to divide everything by the number with y. What are we dividing by? Negative 2. Good. So the number with y is negative 2. Divide everything by that number. All right. So we've taken away the 3x. Step 1, divide everything by negative 2. Step 2, negative 2's cancel out on the left, which gives us y equals negative over a negative is always a positive. 3 over 2 doesn't reduce, so that's just 3 over 2x. And then a negative 14 divided by a negative 2 is a positive 7. So y equals 3 over 2x plus 7. And lastly, let's see, Staley, what's the slope on number 6? So our answer's here. What's the slope of this line here? 3 over 2, good. And what's the y-intercept? 7, nice. So m equals 3 over 2, b equals 7. Okay, so that's it for number 6. Let's keep going. Get the same numbers here. There we go. So number 7. See, Jaden, you're going to be up first on this one in terms of what to do first. So take a look at it, think about it for a second, and then tell me what you think we should do for step 1. Sorry, number 7. Okay, and what are we going to do with the 6x? Are we going to subtract it or add it? Yeah, we're actually going to add this time because this is the first one so far that we've seen where the value with x is a negative. And so what we wrote down for step 1 is add or subtract. We've subtracted every time so far, but we need to add this time because we're starting with a negative number with x instead of a positive number. So to get rid of a negative number, you have to add that same value to get rid of it. So plus 6x on both sides to start this one off. Good. So we add 6x to both sides. All right, and this is a positive 4y, so I'm just gonna write 4y equals 6x, and that's a positive 20, so plus 20. We got 4y equals 6x plus 20. We still have a number next to the value of y. So, Ash, what do we do next? Yeah, just 4. Yep, divide everything by 4. Yeah, we're always going to divide just by the number next to the variable. We're not going to divide by the variable itself. So just divide. Yeah. Okay, cool. So we're going to divide everything by 4. And so that's going to equal, it'll be y equals 6 over 4. Does 6 over 4 reduce? Yeah, what does it reduce to? 3 over 2. So I'm going to write 3 over 2x. And then 20 divided by 4 is 5. So plus 5. We got y equals 3 over 2x plus 5. That's actually the same slope as problem number 6. All right, last but not least, we need to figure out the slope in the y-intercept. So Libby, what do you have for the slope on this one? 3 over 2, good. So just the numbers. And then the y-intercept? 5, excellent. Great. Okay, let's keep going. Number 8. Make sure you can write that down, and we'll scoot on to number 8 here. What should we do before we even start doing any algebra on this one? Put a 1 with the x. Good. So put a 1 with the x. All right. So step 1. Here, let's see. Creed, what do you think we should do first on number 8? Get rid of the minus 1x on both sides? Yeah, so minus 1x on both sides. Good, so we take away the 1x because this time it was a positive, so to get rid of a positive, we subtract it. We have a 5y over here on the left. So 5y equals, always write the term with x first, minus 1x or negative 1x, and then that's a negative 15, so minus 15. So 5y equals negative 1x minus 15. And then the second step, Vanessa, what do you think we should do for step 2 on this one? Divide by 5, excellent. We got to divide by the number next to y. Well done. So divide by 5. So let's see, y equals negative 1 over 5. That's just a fraction, negative 1/5, or negative 1 over 5x. And negative 15, negative 15 divided by 5 is negative 3, so minus 3. Is this starting to feel a little bit like a repeatable process? Because we're kind of doing the exact same 2 things every single time, hopefully. All right, so let's go to Karen. What are the slope and the y-intercepts here? Okay, negative 1/5, yeah. Negative 3, good. So negative 1/5 for the slope, negative 3 for the y-intercept. Cool. All right, that's it for the first page. We're going to move on. We'll keep looking on the second page here. I'll tell you what, we're going to move ahead real quick past 9 through 12 and look at 13 through 15. If we have time, we can go back to 9 through 12 and fill those in quickly. But I want to look at 13 through 15 real quick just to make sure we know what's going on here. So as I mentioned earlier in class today, standard form does not give you slope. Standard form does not give you the y-intercept. So none of these have the slope or the y-intercept numbers in them. And so the directions here are to determine the equation that best represents the line shown on the graph, hence convert them into slope-intercept form. These will be kind of annoying. I'm just going to be upfront about that. The reason is because in order to actually figure out the correct answer, you need to be able to convert those into slope-intercept form and then match it with what's going on here. Ash? Absolutely. I would highly recommend figuring out the slope and the y-intercept of this graph first. Yeah, definitely do that first and then start converting these over here. So let's go ahead and figure out our slope. Now, the difference between this line here and ones that we've seen before is what? What do you notice that's different between this line and the ones that we were using yesterday? There's no dots. So there aren't any dots, so that's up to us. I always recommend one of your dots should be the y-intercept, just because it kind of takes care of two things at once. It gets 1 point to figure out your slope, but it also gives you the y-intercept at the same time. So what is our y-intercept here? What's the value of b? -2. Good. So it's underneath the x-axis by 2 spaces. So our value of b, our y-intercept is -2. Now, if I'm going left to right, we are looking for where the line goes through the corner, directly through the corner of one of the grid lines. So if we follow this line, we get to here, where that line goes perfectly through the corner of a couple of grid lines. How far up is that? How far over is it? So up 1 and over 3. So that means that our slope is 1/3. All right, so we are looking to convert to get an equation of y equals 1/3x minus 2. 1/3x minus 2. The other annoying thing about this problem is that there's not really a lot of room to convert these, right? That's kind of unfortunate. So I'll tell you what we're going to do. I'm going to write number 13 over on the left. 13 over on the left right here. And then I'm just going to start writing. I'm going to write this first one, and I'll start working through it. So we've got 1x plus 3y equals -6. This process is going to be a little bit tedious, but it will be really valuable in terms of continuing to practice those 2 steps that we learned already. Even though it'll be kind of annoying, we might run out of room just in general because we got 3 more to do. We might just do 2 of them. So we'll subtract 1x from both sides, so -1x minus 1x. Bring this down, that gives us 3y equals -1x minus 6. Okay, already I know that this is not the right answer. Anybody figure out why? Before we even do the second step, can you figure out why we know this is not going to be the right answer? Everybody see it? What's that? The y and the x? The x has a negative. Yeah, this negative here. This is a -1x. That's a +3. If we divided everything by 3, that would give us a slope of -1/3. But that's not what we want. We want a slope of +1/3. So we can say right away, okay, this ain't it. Move on. B. All right. Actually, let's take a look here. Yeah, let's do B real quick. Actually, I want to go back to our options real quick before we continue. We know that if we divide by 3, we're going to end up with a fraction of 1/3, right? But it'll be negative. That's not what we wanted. But if we look here, for C and D, hopefully we can see right away that C and D can't work because they're mixed up versions of it. And so if we were to start moving things around, we wouldn't even end up with a 1/3 slope on either one of these. We would end up with a 3/1 slope for these ones, which wouldn't work well at all. So let's try B. I'm kind of thinking it's going to end up being B, but let's see what we get with it. So we got 1x minus 3y equals 6. So we'll try this one. Same first step. Subtract 1x from both sides. So -1x minus 1x. Those cancel out. And then we got a -3y equals a -1x, and that's a +6. I think this one's going to be looking pretty good when we're done with it. So step 1, we subtracted the term with x from both sides. Step 2, divide by the number with y. So what number do we have to divide by here? What number is with y? -3. Good. So divide everything by -3. And this, I think this one's looking pretty good because -3s will cancel on the left. And a -1 over a -3, that's a good thing because negative over negative is always a positive. So that's a 1 over 3x. That's the slope we wanted. What does 6 divided by -3 equal? -2. So that's it right there. Answer is B. All right. So these ones, they're going to require some space and some time and some effort. I want to say on your assignment, there's only 2 problems like that. Yeah, just 2 like that. All right. So what I'm going to do is I'm actually going to go ahead and stop it right there because I want to make sure you have enough time. And we got 21 minutes right now. I want you to keep practicing this, but I would rather you practice this on your assignment, something that I'm actually going to be grading. So I will fill out the rest of these notes and I will post these to Google Classroom. So if you want to see the rest of the answers to this, check in with Google Classroom a little bit later. But let's go ahead and get your assignment out from yesterday. This one right here. And go ahead and keep working through it. Now, you can actually fill in standard form because we have it now. That's that AX plus BY equals C. If you end up needing an extra copy of it, that's okay. Just let me know. I'll get you an extra copy of this assignment. But everybody got a copy of it yesterday. If you misplaced it, let me know. I'll get you another one. You're working on number 10 through 21. So there are, what is that, 12 more questions? Yeah, 12 more questions to work on. About 20 minutes to keep working. So get as much of this done as you can. I will be finishing up the notes up here. I'll be posting these online as well. So if you have questions as you're working through these, please let me know. Follow the 2 steps that we wrote down in our notes. And see what you can come up with. We'll check the answers, by the way, on Tuesday, because that's the next day we have school. Did you find it? All right, cool.